Hi everyone, I'm Teng Yi. Today we will learn about Form 5 Chapter 1 Variation. In this chapter, we will learn about direct variation, inverse variation, and combined variation. Okay, let's start our first direct variation. Okay, in this topic, we will learn about y varies directly as x and relation between three or more variables. Okay, what is direct variation? Direct variation is the relation between two variables such that when variable y increase, then variable x also increase. Okay, in this relation, we can write as y varies directly as x. And this is the variation relation. This is the various symbol. So y varies directly as x. And this is the equation form y equal to kx. It must include k, and the k is a constant. For equation form, we use to find the value of y and x. Okay, next is relation between three or more variables. We call joint variation. Okay, a joint variation is a direct variation in which one variable varies as a product of two or more variables. Okay, like this. Y varies directly as x is a combination of two relations, which is y varies directly as x and y varies directly as z. So this is a variation relation and also equation form. It might include k, and the k is a constant. Okay, here is a tips for your memory. Okay, this is the y varies directly as x. This is square of x. And this is cube of x. This is square root of x. And this is cube root of x. Okay, for y varies directly as z can be read as y varies directly as z and x. And also y varies jointly as x and z. Also, y is jointly proportional to x and z. Okay, after some explanation, we go to our practice question, which include direct variation and joint variation. Let's see question 1. A toy car moved from a state of rest. The distance traveled by a toy car y changed with time t as shown in the table below. So the table is provide our t, time, and our distance y. Determine whether y varies directly as t or t squared. Write the relation in the form of variation. Okay, how do we determine whether y varies directly as t or t squared? We need to use this formula, y over t. So let's see. This is y over t and this is y over t squared. The answer is y over t is the varies directly. Y is varies directly as t because the value of y over t is a constant. So y is varies directly as t. Do you see the answer for y over t is same or is answer 7? So this means y over t is a constant. So this is y varies directly as t. How about t squared? The answer of t squared is all different, right? So this is not. So y is not varies directly as t squared. Okay, let's go to question 2. It is given that p equal to 32 when q equal to 4. Express p in terms of q if, question A, p varies directly as q cubed. Okay, let's see. P varies directly as q cubed. Okay, we need to change into the equation form and it will become p equal k q cubed. Our p have 32 and our q is 4. So let's find the k. Our k is 1 over 2. Okay, we need to express the p in terms of q. So we need to write again this equation and we replace the k. with 1 over 2. So our answer is P equal to 1 over 2 Q cubed. Okay, let's see question B. P varies directly as the square root of Q. P varies directly square root of Q. So P will equal to K square root Q. So our P have 32, Q is 4. So let's 5K. Our K is 16. So write again this equation and replace the K. So P equal to 16 square root Q. Okay, this is the answer for our question 2. Let's go to question 3. It is given that S varies directly as T power 1 over 3. If S equal to 1.2 and T equal to 27, calculate the value of S when T equal to 64. Okay, first we need to find out the value of K. So S varies directly as T power 1 over 3. So become equation form is S equal to KT power 1 over 3. Our S is 1.2 and our T is 27. Okay. Okay, when we see a power in a question, we need to change it into square root form. X power 1 over n equal to x square root n. So for this 27 power 1 over 3, we will change it to 27 cube root. So our K is 0.4. Okay, we write again this equation and replace the K. So our S will equal to 0.4 T power 1 over 3. So now we need to find the value of S when T equal to 64. Okay. 64 power 1 over 3. Same, we need to change it into this form. So become 64 cube root and our S is 1.6. Okay. Question B. Find the value of T when S equal to 0.28. Okay, use this equation. S equal to 0.4 T1 over 3. Okay, our S have 0.28 and let's find T. Okay, we need to times the whole equation power of 3. So will become 0.28 power 3 equal to 0.4 power 3t. So our t will become 0.343. Okay, let's continue our question 4. It is given that the volume of the paint x liters varies directly as the area of the wall dm squared. If 3 liters of paint can paint 36 m squared of wall, question 8, express the equation in terms of x and d. Okay, our x is varies directly as d. So equation form is x equal to kd. And our x is 3, our d is 36. So solve it, find our value of k. So our k is 1 over 12 and x will equal to 1 over 12d. Question B. Calculate the volume of the paint in liters needed to paint a wall of 9 m in height and 5 m in width. Okay, we need to calculate the volume, but it does not provide any area. So we need to find the area with height times width, which is 9 times 5. So our area is 45, which is D. So we use this equation, x equal to 1 over 12 times 45, and our x is 3.75 liters. Okay, question 5. Calculate the constant k for each of the following. P varies directly as cube and r power 1 over 3. Given that P equal to 5.184 when Q equal to 1.2 and R equal to 216. So P varies directly cube and R power 1 over 3. For equation form is P equal to K Q cube R power 1 over 3. Our P is 5.184, our Q is 1.2, and our R is 216. So solve it and find our K. So our K will become 0.5. Okay, question B. P varies directly as Q, R, and the square of S, given that P equal to 1 over 3 when Q equal to 1 over 5, R equal to 3 over 2, and S equal to 1 over 3. So P varies directly as Q, R, and S squared. So for the equation form is P equal to K, Q, R, S squared. So our P is 1 over 3, our Q is 1 over 5, our R is 3 over 2, and S is 1 over 3. Okay, so solve it. And the final answer for our value K is 10. Okay, let's go to question 6. The volume of a cone V cm square varies directly as the height h cm and the square of its base radius r cm. A cone with a height of 21 cm and the radius of 6 cm has a volume of 792 cm cubed. Calculate the volume in cm cube of a cone with a height of 14 cm and a radius of 15 cm. So for now, our volume is V, and we have 792 cm cubed. Our height is h, and we have 21 cm, and the base radius is r, and we have 6 cm. So let's find the value k first. So V varies directly height and square of r. So V will equal to k h r squared. So solve it, and our k will become 22 over 21. And V will equal to 22 over 21 hr squared. So for now, we need to calculate the new volume with a height of 14 cm and a radius of 15 cm. So use this equation. V equal to 22 over 21 hr squared. Replace the h and r with 14 and 15. So our new volume is 3,300 cm cubed. Okay, question 7, which is the last question for our direct variation. Amina wants to cut a few triangles from a piece of card. It is given that the area of the triangle cut a cm cube varies directly at its base x cm and its height y cm. At the beginning, she cut a triangle with a equal to 14, x equal to 7, and y equal to 4. So question 8, write the relation between a with x and y. Okay. So a is varies directly as x and height. So a will equal to kxy. For our a is 14, our x is 7, and our y is 4. So our k is 1 over 2, and a will equal to 1 over 2xy. Okay. Question B. Amina's plan to cut a second triangle with the value of base increased by 12% and the value of height decreased by 10%. What is the percentage of change in the area of the second triangle? Okay. For our previous base is 7 cm. So for now, we need to increase 20%. So 7 times 20 over 100 equal to 1.4. And we need to plus the previous base cm as it increased. So the new base value is 8.4. Okay, for the height, for the previous height is 4 cm. For now, we need to decrease by 10%. So 4 times 10 over 100 equal to 0.4, and we need to use 4 minus by 0.4, we get the new height value is 3.6. So we calculate the new area. So our new area is 15.2 12 cm squared. Okay, so what is the percentage of the change in the area? For the percentage of change in the area, we need to use the new area minus by the previous area and times our previous area. So we get 0.08, which is 8%. So there is a 8% of change in the area. Next, we go to our second, inverse variation. What is inverse variation? Inverse variation is when the variable y increase, then the variable x will decrease. This relation can be written as y varies inversely as x. Okay. This is the variation relation of y varies inversely as x. It will become y equal to k over x. This is the equation form. For the same, where k must be a constant. Okay, these are tips for your memory. This is y varies inversely as x. This is square of x and square root of x and the cube root of x. So the relation of inverse variation written as y varies inversely as y can also be written as x and y are inversely proportional. Okay, let's see some practice question for more understanding about inverse variation. Okay, question 1. The table below show the value of two variables x and y. Determine whether y varies inversely as x. If yes, write the relation in the form of variation. Okay, to determine the y varies inversely as x, we need to see whether the k is a constant. So we use this formula. Okay, y varies inversely as x means that y equal to k over x. So here is the answer. For the k is not a constant. So y does not vary inversely as x. Okay, question B. Y varies inversely as x squared. Also, determine is varies or not. Okay, use the formula y equal to k over x squared. Here is the answer. Okay, for the k is a constant. So this is a y varies inversely as x. Okay. Question 2. A company prints a certain number of books every day. The table below shows the number of printing machine in operation M and the time needed T to print the book. It is given that T varies inversely as M. Question A. Express T in terms of M. Okay, T is varies inversely as M. So for our equation form will become T equal to Km, K over M. And now we'll use this information and our T have a value of 10 and our M is 6. So our K is 60. So T will equal to 60 over M. Question B. Determine the value of P and Q. Okay, use this equation to find our value of P and Q. Okay, find our P value first. So for now, our P is value T. So our T will replace by P. So we have an N with value of 8. So our P is 7.5. Next is our value of Q. Our value of Q is M. So our N will replace by Q. And we have value of T is 4. So T equal to 60 over M. And our T is 4. So 4 equal to 60 over Q. So our final value of Q is 15. Okay, question 3. The period of oscillation T of a simple pendulum varies inversely as the square root of gravitational acceleration G. In an experiment, the period of oscillation is 1.01 seconds, when the gravitational acceleration is 9.85 ms power -2. Express t in terms of g. Okay, t is various inversely as square root of g. So for the equation form, it will become t equal to k over square root g. Our t is 1.01 and our g is 9.85. So solve it. And our k will become 3.17. And we need to express the t in terms of g. So our t will equal to t will equal to 3.17 over square root g. Okay, proceed to our question 4, which is the last question for our inverse variation. Okay, the number of oscillation A of a simple pendulum varies inversely as the square root of the length of the pendulum PCM in a fixed period. Given that the number of oscillation is 9, when the length of the pendulum is 36 cm. Calculate the length of the simple pendulum if the number of oscillation is 15. Okay, let's see. Our A is various inversely as the square root of P. So the equation form will become A equal to K over square root P. And our A has a value of 9 and P is 36. So our K is 54 and A will equal to 54 over square root P. And we need to calculate the length if the number of oscillation is 15. Means that when our A is 15, what is our length? So when A equal to 15, P is A equal to 54 over square root P, and our A is 15. Okay, we need to power the whole equation with 2, and we get 15 power 2 equal to 54 square over P. So our final P is 12.96 cm. Okay, next is our last subtopic, which is combined variation. What is combined variation? Combined variation involves a combination of direct variation or joint variation and inverse variation. For a combined variation, y varies directly as xm and inversely as secant can be written as, okay, this is the variation relation. Y varies directly xm over inversely secant, and the equation form will become like this. Okay, for the same, k is a constant. Okay, so this is the y varies directly as w and the cube of x, and inversely as the cube root of z. The second one is y varies directly as the product of w square and square root x, and inversely z cube. Okay, now we go practice question. Okay, question 1. It is given that m varies directly as the square of n and inversely as p. If m equal to 4.8 when n equal to 6 and p equal to 1.5. Calculate question B. The value of p when n equal to 0.8 and n equal to 2.4. Okay, let's calculate the value of k first. Okay, n is varies directly as square of n and inversely p. So for the equation form will become m equal to kn squared over p. Our m is 4.8 and our n is 6, p is 1.5. So our value of k is 0.2. So m will equal to 0.2 n squared over p. Okay, so now we need to find the value of p when n is 0.8 and the n is 2.4. Use this equation. Okay. So our P will equal to 1.44. And the question B is find the value of N when N equal to 19 and P equal to 3.8. Also use this equation. Okay, solve it and our N will become 19. Okay, next go to question 2. The table on the right show the change in three quantity T, E, and F. It is given that T varies inversely as the square root of E and the cube of F. Calculate the value of A and B. Okay, let's see this table. We need to calculate the value of A and B. So we need to use this first row information to find our K first. Okay, T varies inversely square root of E and cube of F. So the equation form will become T equal to K over square root E and cube F. For our T, we have 5. For our E, we have 1.44. And for our F, we have 2. So we solve it and find our value of K. So our K is 48. So T will equal to 48 over square root E cube F. Okay. So now we find our value of A first. Okay. Value of A equal to T. So our T will replace by A. So use this equation. So our A will equal to 48 and our E have 36 and our F have 0.4. So solve it and our A will become 125. Okay. Next is find value of B. So value of B, E is replaced by B. So use this equation. We have our T is 0.256 and our F is 5. So we need to find the value of B. So our B is 2.25. Okay, let's continue our question 3, which is the last question for our combined variation. The average number of daily phone calls C between two cities varies directly as the population of the two cities P1 and P2 and inversely as the square of the distance J between two cities. The distance between two city A and city B is 210 km. The average number of daily phone calls between two cities is 15,750 and the population of city A and city B are 105,000 and 220,000 and 500 respectively. Give your answer to the nearest whole number. Calculate question A. The distance between city P and city Q if the population are 83,400 and 62,000 respectively and the average number of daily phone call is 19,151. Okay, question B. The population of city J if the population of city K is 1,100,000 with the distance between the two cities is 351 km. The average number of daily phone call between city J and city K is 18,857. Okay, let's see. For now, our average number of daily phone call is C, and we have 15,750. And our distance J is 210. And our P1 is 105,000 and P2 is 220,500. Okay, let's see our question A. Our question A is we need to find the K first and solve question A. So C is varies directly P1 and P2 and inversely square of J. So the equation form will become C equal to K P1 P2 over J squared. So we solve it and we get our K is 0.03. So our C is 0.03 P1 P2 over J squared. Okay, now we need to find the distance between city P and city Q. So if the population is city P will equal to P1, so is 83,400 and city Q is P2 and is 62,000. So and the average of Punko is 19,151. So we use this equation to find the distance. Okay. So our J, which is distance, will become 90 km. Okay. For question B, our city K, which is P2, will equal to 1,100,000 and the distance is 351 and the average of phone call is 80,857. So for here, we need to find city J, which is P1. Okay, use this equation, C equal to 0.03 P1 P2 over J squared and solve it. So our P1 will equal to 70,400 people. Okay, that's all for this chapter. Thank you and don't forget like, share and subscribe.